Hello and welcome to Module 6 of our MOOC about biodiversity and global change. In this module we want to talk about the past, present and future of biodiversity. We want to discuss the ups and downs that biodiversity has experienced throughout the last few billion years, the threats it is currently facing in the form of global change, and how we can make predictions about the future of species. The term global change refers to any worldwide change in our planet system. Most of these are caused by human beings. This includes climate change and everything that comes with it, but also many other types of changes like human population growth, expansion of cities, biodiversity loss, desertification, overfishing of the oceans, and an increase in the amount of garbage. Climate change is, generally speaking, any change in climate that is large in scale and lasts more than a few years. Short-term changes and fluctuations, like El Niño, are not considered climate change. Nowadays, the term is often used to refer specifically to the current climate change. In the next lesson, my colleagues are going to talk about global change. In this lesson, I'm discussing past challenges to biodiversity in this video and the current climate change in the next video. Our planet formed around 4.5 billion years ago. The colored boxes at the top of the screen represent these 4.5 billion years. The turquoise-colored box, representing the most recent 542 million years, we call the Phanerozoic. The earliest part of the Phanerozoic, here shown as the black rectangle, is called the Cambrian. That's why the entire time from the formation of our planet until 542 million years ago, here shown in red, is called the Precambrian. So the Precambrian lasted about 4 billion years, which is approximately 8/9 of the total time. At the beginning, Earth was extremely hot and all water was present only as water vapor. It took a long time for the planet to cool down. When the temperature dropped below 100 degrees Celsius for the first time, most of the water vapor condensed to become liquid water and formed the first oceans. At that time, the atmosphere was still free of oxygen. The presence of water in its liquid form opened the way for the chemical evolution. In what is called the primordial soup, various inorganic molecules assembled to form the first organic molecules. Some of these assembled to form the first RNA molecules. Lipid molecules were also formed and spontaneously assembled into liposomes. These liposomes and RNA molecules might have combined to form the first protocells. Eventually, these first cells acquired the ability to multiply by splitting, and in such a way the first life formed. These cells were probably similar to today's bacteria. One new bacterial lineage, the Cyanobacteria, evolved the ability to perform photosynthesis. That is, they were able to use the sun's energy to transform carbon dioxide into organic molecules and free oxygen. The free oxygen led to an oxygenation of the methane in the atmosphere, so that the concentration of methane dropped. Since methane is a powerful greenhouse gas, its removal caused a significant drop in temperature on Earth, and eventually most of the planet was covered in snow and ice. This is called the Snowball Earth hypothesis. So now there was free oxygen in the atmosphere for the first time since the formation of the planet. This was a problem for anaerobic bacteria, and most of them went extinct. So this was the first extinction event of a majority of existing species, and it is called the Great Oxygenation Event or oxygen catastrophe. In the meantime, aerobic bacteria evolved and were doing well in this newly oxygenated atmosphere. About 1.5 billion years ago, the first eukaryotes evolved. I hope that you remember from the first module that eukaryotes are organisms that have a nucleus and organelles and comprise the four kingdoms Protoctista, Animalia, Plantae, and Fungi. Close to the end of the Precambrian, the planet went through a cold phase caused by a decrease of the concentration of carbon dioxide in the atmosphere. Again, large parts of Earth were covered in ice and snow. About 630 million years ago, this cold period ended because of many volcanic eruptions. These eruptions led to an increase in the carbon dioxide concentration in the atmosphere, which increased the greenhouse effect and led to global warming. It led to a melting of the glaciers, which brought not only water, but also many minerals to the sea. And this caused a rapid growth of the algae in the oceans, and thereby a further increase of oxygen levels in the atmosphere. Now, finally, oxygen concentration was at a level similar to today, which enabled the formation of truly multicellular creatures. The Ediacaran, the last period of the Precambrian, is the first period in the history of Earth from which we have fossils of multicellular organisms. These are very strange-looking creatures that don't really resemble anything we know from later times. We're not sure what kind of creatures they were. This one might be an arthropod or an annelid worm, hard to say. At the boundary of the Precambrian and the Phanerozoic, the Ediacaran biota disappeared almost completely, but we don't know why. So that was another mass extinction event. For the rest of the video, I'm going to talk about the Phanerozoic. It began 542 million years ago and is still going on. It is divided into 12 periods: the Cambrian, Ordovician, Silurian, Devonian, Carboniferous, the Permian, Triassic, Jurassic, Cretaceous, the Paleogene, Neogene, and the Quaternary. In this graph, the blue line represents the amount of biodiversity in terms of the approximate number of genera known to science. The red line is the trend line. Overall, the amount of biodiversity has increased a lot throughout the Phanerozoic, but you can clearly see the ups and downs. The 5 biggest decreases in biodiversity are known as the Big 5 mass extinction events. In addition to these Big 5, there were at least 6 other mass extinctions. As you can see, many of the boundaries between periods are at the end of mass extinctions. This is not a coincidence, as the periods were defined by geologists to begin and end at significant changes in the history of Earth. But let's begin at the start of the Phanerozoic, the Cambrian. At the beginning of the Cambrian, there was a large increase of biodiversity called the Cambrian explosion. There have been other times in the history of Earth when the increase in the number of genera was similarly fast, but what's unique about the Cambrian explosion is that most of the major animal phyla evolved for the first time during this period. For example, the arthropods, like these trilobites, and the mollusks. Even the chordates, which is the phylum to which we humans belong, were already present in the Cambrian. There was an extinction in the second half of the Cambrian, but this is not counted as one of the Big 5. The first of the Big 5, the Ordovician Silurian extinction event, happened about 440 million years ago. It was probably caused by a global cooling event. The late Devonian extinction wasn't as fast as the other 4 of the major extinction events. It lasted at least 20 million years. The cause is not clear. The Permian Triassic extinction was the worst extinction event in the history of biodiversity. Volcanic eruptions near Siberia released large amounts of carbon dioxide into the atmosphere. In addition, lots of methane might have been released. The increased concentration of these greenhouse gases probably caused global warming and ocean acidification. There was also a lack of oxygen in the oceans. Due to this, over 90% of all species became extinct, including all trilobites. The Triassic-Jurassic extinction event happened about 200 million years ago. We're not sure about the cause. The Cretaceous-Paleogene extinction event happened about 66 million years ago. It was probably caused by a combination of events. First, there were many volcanic eruptions, which led to a climate change. This already caused great declines in the number of individuals, and many species went extinct. Then, a gigantic asteroid hit the Earth near Mexico, which delivered the final blow. About 75% of all species became extinct, including all of the dinosaurs, except for the birds. Since the last major extinction, the amount of biodiversity has been going up fairly steadily, until human beings evolved. At present, we're probably at the beginning of another major extinction event. Contrary to the other extinctions, this one is caused by human beings. For this reason, it has been proposed that we have entered a new epoch. But what is an epoch? At the beginning of this video, I mentioned that the Phanerozoic is divided into 12 periods. Each of the periods is divided into 2 or more epochs. The current period, the Quaternary, is a small sliver of 2.6 million years. It is divided into two epochs, the Pleistocene and the Holocene, which began only 12,000 years ago. It has recently been suggested that the influence of humans on the physical and biological environment is so severe that we should consider the present time a new epoch, and that this epoch should be called Anthropocene. The word anthropos is Greek and means human being. The choice of the name reflects the fact that human beings are the cause of the current global changes. It is currently being debated which moment should be considered the beginning of the Anthropocene. Many argue that this should be the year 1950 because that's when the rate of change in many aspects of life on Earth suddenly accelerated significantly. We'll talk more about this great acceleration in the next two videos. Thank you for staying with me through 4.5 billion years.